In this question, we have to find the coefficient of x cube in the expansion of 1 plus kx into 1 minus 2x to the power 5 is 20. We have to find the value of the constant k. Now, now to find the coefficient of x cube, 1 plus kx needs to be multiplied by a term in x square and a term in x to the power 3. So 1 will multiply by x cube and it will give us a term in x cube. The kx will multiply it by x square and it will give us a term in x cube as well. We'll add it up and equate it to 20. Now to expand 1 minus 2x to the power 5, we just need the coefficient of x square and x cube. So we can write it as 5c2. The value of b is minus 2x, so minus 2x to the power 2 plus 5c3 minus 2x to the power 3. Simplifying this, we get 5c2 is 10, so 10 multiplied by 2 whole squared is 4, so we get a 440x squared. 5c3 is also 10 and minus 2 cube is minus 8, so this will become a minus 80x cube. Now multiplying 1 by minus 80, we get a minus 80x cube, and multiplying kx by 40x square, we get a positive 40x square, positive 40x cube. Now simplifying this, so we have a k as well, so this will become 40x cube k. Now we know that the coefficient of x cube over here can be written as minus 80 plus 40k, and this is equals to 20. So we can put it as minus 80 plus 40k is equals to 20. Solving this, we get 40k is equals to 20 plus 80, which is 100. So k is equals to 100 upon 40. And simplifying this, we get k is equals to 5 upon 2. In this question, we have three geometric terms, 2p plus 6 minus 2p and p plus 2, where p is positive. We have to find the sum of infinity of the progression. Now, what we know about the common ratio of a geometric progression is that to find the common ratio, we divide two consecutive terms together, meaning we can divide the second term by the first term, or R could also be the third term divided by the second term. It could also be the fourth term divided by the third term. What we need to understand is that it will always be two consecutive terms that are dividing with each other. Now we know that the second term is minus 2p, so we can write r is equals to minus 2p divided by the first term, which is 2p plus 6, and r can also be written as the third term, which is p plus 2 divided by minus 2p, which is the second term. Now as it is a single geometric progression, the common ratio must be the same, so we can equate these two equations and find the value of p. So solving this, we get minus 2p into minus 2p, which is 4p squared. 2p plus 6 multiplied by p plus 2 would become 2p squared plus 4p plus 6p plus 12. Simplifying this, we get, so 4p square minus 2p square is 2p square. 4p plus 6p is 10p, so this will become minus 10p minus 12 is equals to 0. We can write it as p square minus 5p minus 6 is equals to 0. Factorizing it and solving it, we get p minus 6 and p plus 1 is equals to 0. So the two values of p are p is equals to 6 and p is equals to minus 1. Now as p has to be positive, so this is the value of p that we will be taking for the next part, which is finding the sum of infinity. Now the formula for the sum to infinity is a divided by 1 minus r. So a is the first term and r is the common ratio. So we know that a is equals to 2p plus 6. So a is equals to 2p plus 6. Taking p is equals to 6, we get a is equals to 18. 2 times 6, 12 plus 6, 18. The common ratio can be taken as minus 2p divided by 2p plus 6. Substituting 6 into the equation, we get minus 12 upon 18, which makes r is equals to minus 2 upon 3. Now substituting these values into the formula for sum to infinity, we get a is equals to 18 divided by 1 minus minus 2 upon 3. Simplifying this, we get 18 divided by 1 plus 2 upon 3, which is 5 upon 3. And simplifying this, we get 18 multiplied by 3 upon 5, which is 54 upon 5, or we can give it as 10.8. So this is a sum to infinity of the geometric progression. In this question, we have the equation of a curve and where m is a constant and the equation of a line is y is equal to 6x plus 4. We have to show that for all values of m, the line intersects the curve at two distinct points. Now, whenever we have an unknown constant in an equation, we always use a discriminant, which is b squared minus 4ac, to find that value. However, in this case, we just have to show that for the values of m, the line is intersecting at two distinct points, which means that this equation must be greater than 0. So to form this equation, first we'll equate the equation of the curve and the equation of the line. So we get 2x squared plus m into 2x plus 1 is equals to the equation of the line, which is 6x plus 4. Now simplifying this, we get 2x squared plus 2mx minus 6x plus m minus 4 is equals to 0. So from here, we can reduce that a is equals to 2. B is the coefficient of x. So in this case, that will be 2m minus 6. If we take x common from over here, we will get 2m minus 6 as the coefficient, and c would be m minus 4. Now putting this up in the equation b squared minus 4ac, we have 2m minus 6 whole squared minus 4 into a, which is 2, and c, which is m minus 4, and this is greater than 0. So expanding this, we get 4m squared plus 20 minus 24m plus 36 minus 8m plus 4 2s are 8 times 4 32. Simplifying, we get 4m squared minus 32m plus 32 plus 36, which will become 68, is greater than 0. Simplifying, we get m squared, so we can divide the whole equation by 4. We get m squared minus 8m plus 17 is greater than 0. Now we have to show that this equation is greater than 0, which means that if we make the x-axis, below it is the negative part and above it is the positive part. So we have to show that this equation lies above the x-axis or it is greater than 0. We can do that by finding the turning point of this curve. So we find the turning point by converting our equation in the form y is equals to a into x minus h whole squared plus k. In this case, our variable is m instead of x. So to convert this into the full square form and then finding the turning points, because by finding the turning points, we'll be able to prove that the whole equation, whole curve lies above the x-axis. So expanding this, we have y is equals to ax square minus. Okay, so what we can do is, first of all, we can just expand the bracket. So we get a multiplied by x square minus 2xh plus h square plus k, which will become ax square minus 2axh plus ah square plus k. Now to avoid any confusion, we can just use a variable m instead of x over here, or in this equation, we can use a variable x. So to find the values of a, h, and k, we can compare the equations that we have. So this is the form of the full squared form, and this is the equation that we have, which is m square minus 8m plus 17. From this, we can deduce that a is equals to 1 because that is a coefficient of m squared. The coefficient of m over here is minus 2ah, which is equals to minus 8. And the constant is ah square plus k, which is equals to 7. So as a is 1, so minus 2 times 1 is minus 2. So h will become minus 8 upon minus 2, which is positive 4. And now substituting a and h over here, we get 1 into 4 squared plus k is equals to 7. So this will become k is equals to 7 minus 16, which will become k is equals to minus 9. Okay. So, okay, so this is not 7, this was 17. So 17 minus 16 would become a positive 1. Now putting this up in the form y is equals to, so we have a as 1, x minus 4 whole squared plus 1. From here we can show that the turning point of this curve is 4 comma 1, which is basically above the x-axis. So it has a minimum point. As a is greater than 0, it means the minimum point is above the x-axis. As this point is 4 comma 1, it means the curve can never go below the point y is equals to positive 1. So we can, so this is how we prove that the whole curve is above the x-axis. And this is basically how we show that for all values of m, the line intersects the curve at two distinct points. So we had to prove that this whole curve is above the x-axis or greater than 0. Now in this question, we have an arithmetic progression and the sum is given by n square plus 4n. We have to find the kth term in the progression, which is greater than 200. And we have to find the smallest possible value of k. So to find the general term, or to find the nth term of our arithmetic progression, we know that the formula is a plus n minus 1 times d. Now, as we have the sum given, so we can compare it with the formula of the sum that we know for arithmetic progression, which is n upon 2 into 2a plus n minus 1 times d. And this is equals to n square plus 4n. Now, comparing these two equations, we'll be able to find the values of a and d. Now, we can bring the 2 on the other side, and expanding this bracket, we will have 2a plus nd minus n is equals to 2n squared plus 8n. Now expanding this, we have 2an plus n squared d minus n. So this is d times 1, which is d up here. So this will become nd is equals to 2n squared plus 8n. Now the coefficient of n square over here is d, and over here it is 2. So we can reduce that the value of d is 2. The coefficient of n over here can be written as, so this is 2an minus nd. Taking n common, we have 2a minus d. And on the right hand side, the coefficient of n was 8. So we can say that 2a minus d is equals to 8, as 2a minus d. So this would be 2a minus d. And as d is equals to 2, so we get 2a is equals to 8 plus 2, 10. So a will be is equals to 5. So we have the formula for the nth term, which is 5 plus n minus 1 into d, which is 2. Now we have to find the value of n such that it is greater than 200. So we can write this formula as 5 plus n minus 1 into 2. In this case, it is k, so we can replace it with the k later on, and this is greater than 200. So solving this, we get 5 plus 2n minus 2 is greater than 200. Simplifying, we get 2n is greater than 200 minus 5 plus 2. So 2n is greater than 197, and n is greater than 98 point. So this will become 98.5. As n is an integer, so and it is greater than 98.5, So n should be equals to 99. Now in this question, we have two functions, and the first part we have to find the value of f g of 7. To that, the first step is finding f of g. So f of g is basically 4, and in place of x, we'll put the function g, which is 4 into 4 upon x plus 1 minus 2. Now putting up 7 in place of x, we have 7 plus 1, 8 minus 2. So this is 16 upon 8, which is 2 minus 2. So fg of 7 would become 0. In the next part, we have to find the values of f inverse of x for is equals to g inverse of x. Now to do that, the first thing we need to do is find the inverse of f and the inverse of g. Now the step to find inverse is, first of all, we can write the function f, which is 4x minus 2. We can replace the f of x with a y, and as we are finding the inverse, so we'll switch the values, the y value with x and the x value with y. And finally, by making y our subject, we'll get the inverse of the function. So f inverse is x minus 2 upon 4. So we can write it as f inverse of x is equals to x minus 2 upon 4. For g inverse of x, we'll follow the same steps. So g inverse of x is 4 upon x plus 1. So writing y in place of g of x is the first step, and then interchanging the values of x and y, we get x is equals to 4 upon y plus 1. Cross multiplying, we have xy plus x is equals to 4. So xy is equals to 4 minus x, and y is 4 minus x upon x. So finally, we can write g inverse of x is equals to 4 minus x upon x. Now we have to equate this as it says the values of x for which f inverse is equals to g inverse. So we write x minus 2 upon 4 is equals to 4 minus x upon x. Cross multiplying, we have x square minus 2x is equals to 16 minus 4x. Bringing the right hand side, on the left hand side, we have x square minus 2x plus 4x minus 16 is equals to 0. This will become x square plus 2x minus 16 is equals to 0. Okay, so this was not a minus 2, this was a plus 2 over here. So changing this plus 2 would make this not a 2x, but this will be 2x plus 4x, which will become a 6x. So yeah, so when this was also partly, this was also wrong, because as the 2 moved on the other side, it should have had become a positive 2. All right, so continuing over here, now we'll just solve this by factorizing. So this will become x square plus 8x minus 2x minus 16 is equals to 0. And this will become x into x plus 8 minus 2 into x plus 8. Finally, the two values of x would be x equals to 2 and x equals to minus 8. In this question, we have to prove an identity. So on the left hand side, we have 1 upon cos x minus tan x and multiplied by 1 upon sin x plus 1. And we have to prove that it is identical to 1 upon tan x. So we can start off by applying the identity tan x is equals to sin x upon cos x. So this will become 1 upon cos minus sin upon cos. And we can take the LCM over here. So this will become 1 plus sin upon sin x. So simplifying this side, we get 1 minus sine upon cos, and this will be 1 plus sine upon sine. So using the algebraic identity, we have 1 minus sine squared upon sine cos. As we know that x squared minus y squared can be written as x minus y, x plus y. Now we know that the identity for cos square plus sine square is equals to 1. So we know that cos square is 1 minus sine square. So in place of 1 minus sine square, we can replace it with cos squared. Cancelling cos and cos squared, we have cos upon sine, which is equals to 1 upon tan x. Now in the next part, we have to solve the equation where this is equals to 2 tan square x. Now we know that this side can be written as 1 upon tan x. So we can write 1 upon tan x is equals to 2 tan square x. Taking the tan on the other side, we have tan cube 1 is equals to 2 tan cube. So tan cube is equals to 1 upon 2. Now as our range is 0 to 180, we know that tan is positive in the first and the third quadrant. However, as our range is only from 0 till 180, so we'll only take the angle in the first quadrant. So in this quadrant, all angles are positive, and sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. So taking tan inverse of 1 upon 2, we get our basic angle is 38.4 degrees. So this angle is 38.4, but as we cannot go outside 180, so that will be our only answer. So theta would be is equals to 38.4. We always measure this theta angle from the positive x-axis in an anti-clockwise manner. In this question, we have a point that lies on the curve and the derivative of the curve. So this f dash x is the derivative of the curve. A point moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.12 units per second. So as soon as we have a rate of change in any question, we know that y and x are related by the equation dy dt is equals to dy dx multiplied by dx by dt. Now we have to find the rate of increase of y. So this is our unknown. This is given as 0.12, and we can find the dy dx by substituting x equals to 4 into this equation. So our dy dx would be 6 multiplied by 4 to the power negative 1 upon 2 minus 4 multiplied by 4 to the power minus 3 upon 2. Finding this, we get dy dx is equals to 5 upon 2. So dy dt would become equals to dy dx, which is 5 upon 2 multiplied by dx by dt, which is 0.12. So the final answer is 0.12, which is the rate of increase of y. So 0.12 units per second. Now to find the equation of the curve, what we do is we integrate the derivative. So we have the derivative. So f dash x is equals to 6x to the power minus 1 upon 2 minus 4x to the power minus 3 upon 2. Integrating this both the sides, we get y is equals to, so we add 1 over here and then divide by the new power, which is positive 1 upon 2. So we have 6x to the power 1 upon 2 divided by half minus 4x. So when we add minus 3 upon 2, when we add 1, we get negative half. And then we divide this by negative half. Simplifying this, we get y is equals to, and we always have to put a plus c up here. So we get 12x to the power 1 upon 2 plus 8x to the power negative 1 upon 2 plus c. Now to find the value of c, we substitute the 0.4 and 7 to the equation. We have 7 is equals to 12 into 4 to the power 1 upon 2 plus 8, 4 to the power negative 1 upon 2 plus c. This will become 7 is equals to 12 times 2, which is 24 plus, and this will become 8 upon 2. So this will become 4 plus c. So c is equals to 7 minus 24 minus 4, which is minus 17 minus 4, which is minus 21. So the final equation would be y is equals to 12x to the power 1 upon 2 minus plus 8x to the power negative 1 upon 2 minus 21. In this question, we have a triangle ABC, which is an isosceles triangle, and we have a point D that lies on AC, and ABD is a sector. So we know that this is a question about circular measure. We have to express the area of the shaded region in terms of r and theta. So to find the area of the shaded region, first we find the area of the triangle and subtract the area of the sector ABD. So the area of the triangle ABC would be half AB sine C. So half, we have the two lengths which are R and R, and we need the angle between them. So we know that the formula for area of a triangle is half AB sine C. Now as these two lengths are equal, it means this angle would also be theta, which means that this angle would be 180 minus 2 theta. So the area would be half into R, which is R square, into sine of theta minus 2 pi. Now from our trigonometry, we know the identity that sine theta is the same as sine of 180 minus theta. So applying that over here, as pi is 180, in place of pi minus 2 theta, we can write half into r square into sine of 2 theta. So this is the area of the triangle. Now to find the area of the sector, we have the formula half r square theta. So it will remain as it is, as the radius is r and the angle is theta. So the area of the shaded region would become the area of the triangle minus the area of the sector. So this would become half r square sine 2 theta minus half r square theta. Now we can simplify this and write it as half r square is common. So we can write it as sine 2 theta minus theta. So this is an expression for the area of the shaded region. Now in the next part, it says in the case where r is equals to 10 and theta is equals to 0.6, we have to find the perimeter of the shaded region. Now to find the perimeter, we need to understand that the length DC plus the arc DB and the length BC will basically make up the perimeter of the shaded region. So to begin with, we can write that the perimeter would be the length of BC plus the length of DC plus the arc length arc BD. Now to find the length of DC, so if we find the total length of AC and subtract the length of AD, we will be able to find the length of DC. So the total length of AC we can find by using the cosine rule. So we can write AC square. Now as we have the two lengths and the angle between them, so this, let's say this is C or AC. So we write AC square is equals to R square plus R square minus 2 times R cos of theta minus 2 pi. Simplifying this, we get AC square is equals to 2R square minus 2R square. And now applying the identity for cos, which is cos of theta is equals to negative cos of 180 minus theta. So as we have pi minus 2 theta, so this can be written as negative cos of 2 theta. So AC square would become 2R squared plus 2R squared cos 2 theta. Now we have the values of r and theta, we can substitute them up there. So substituting the values of r and theta, we get square root of 2 times 10 squared plus 2 times 10 squared into cos of 2 times 0.6. Finding this value in the calculator, we have AC is equals to 16.506 centimeters, or whatever the unit is. Now for the length of DC, it would become 16.506, which is the total length of AC minus the radius 10. So the length of DC would become 6.506. Now to find the arc length BD, we just simply use the formula r theta. So the arc length BD is equals to r theta. R is 10 and theta is 0.6. We get arc length as 6. Finally, for the perimeter, we add all the three lengths. So the perimeter would be the sum of the three lengths, and one of the lengths is R, which is known. We have the length of DC and the arc length BD. So it would become 10 plus 6. So this is the radius. This is the arc length. And this is the length of DC, 6.506. So this is the length of DC. So the perimeter would come out to be equal to 22.506. And as we have to give our answer in terms of in three significant figures, so the final answer would be 22.5. And we can, so it will be 22.5 centimeters as our unit are in centimeter. And this question is you have to find the equation of the circle. We know that the equation of the circle is given as x minus a whole squared plus y minus b whole squared is equals to r squared, where a comma b are the center of the circle and r is the radius. So this is the center and r is the radius. So we have the center as 5 comma 1. So we can write x minus 5 whole squared plus y minus 1 whole squared is equals to r squared. Now what we need to understand is that this is the center and this is a point that lies on the circle. So the distance between these 2 points will be the radius. So we can find the radius by using the distance formula. So r would become x2 minus x1 plus y2 minus y1 whole squared. So this would become minus 1 minus 5 whole squared plus minus 2 minus 1 whole squared. We get 36 plus 9, which is square root of 45. So the equation would become x minus 5 whole squared plus y minus 1 whole squared is equals to square root 45 whole squared, and cancelling out the square root with the square, we have x minus 5 whole squared plus y minus 1 whole squared is equals to 45. In the next part, we have a point C such that AC is the diameter of the circle. Point D has coordinates 5, 16. We have to show that DC is a tangent to the circle. Okay, so to show that anything is a tangent, what we first have to understand is that if we have a circle and we make a radius or a diameter, the tangent always makes a right angle with the radius or the diameter. We also know that this point is B, which is the midpoint. So let's say if this was A and this is C, B would be the midpoint. So we can find the coordinates of C by using the midpoint formula. We know that the midpoint is 5, 1, the coordinates of B. The coordinates of A are given, which are minus 1 and minus 2. So we can write this as minus 1 plus x upon 2, comma, minus 2 plus y upon 2. So the coordinates of A are minus 1 and minus 2, yes. So now equating this, equating 5 with the x coordinate, we have 5 is equals to minus 1 plus x upon 2, and 1 is equals to minus 2 plus y upon 2. Simplifying this, we get x is equals to 11 and y is equals to 4. So the coordinates of C are 11 and 4. Now the coordinates of D are given as 5, 16. And we have to show that DC is a tangent. So what we can do is we can find the gradient of AC, we can find the gradient of DC, and we can show that they're negative reciprocals of each other. As if two lines are perpendicular, their gradients are negative reciprocals. So the gradient of CD would be y2 minus y1. So we can write 16 minus 4 divided by x2 minus x1, which will become 5 minus 11. So this will be 12 divided by minus 6, which is minus 2. And the gradient of AC would be, so the coordinates of A are minus 1 and minus 2, and the coordinates of C are 11 and 4. So we can say y2 minus y1 would be minus 2 minus 4 divided by minus 1 minus 11. So this would simplify down to become positive 1 upon 2. Now, as we have the two gradients, to show that they are perpendicular, we can just show that the two gradients when they multiply, the answer would be negative 1. And this shows that the two lines are perpendicular. So multiplying minus 2 by half as we have a minus 1, hence it's proven that the DC is perpendicular to the circle, as AC is the diameter and the gradients are negative reciprocals, so we can say that DC is a tangent to the circle. Now in this part we have that there is another tangent from D that touches the circle at E. We have to find the coordinates of E. Now it is always easier to understand these questions if you are able to draw a rough diagram. So in this question we have B, which is the center, A has coordinates -1, -2, AC is the diameter, and D has coordinates 5, 16. And the other tangent from D is touching the circle at E. So let's say if we draw a line from D, the point E would be roughly over here. Now, as the coordinates of DC was -2, the gradient of DC was -2, and we know that this is a right angle, and if we make a radius over here, this will also be a right angle. These two triangles are symmetrical. If this has a gradient of -2, the line ED would have a gradient of +2. Now, we know that to find the equation of DE, first of all, we can write it as y is equals to mx plus c. We know that the gradient is 2, so we can write it as 2x plus c, and we can find the value of c by substituting the coordinates of d, which are 5 and 16. So substituting them in this equation, we get 2 times 5 plus c, so this will become c is equals to 16 minus 10, which is 6. So the equation is y is equals to 2x plus 6. Now to find the coordinates of E, as we know that the line and the circle are intersecting, we can solve the two equations simultaneously. So the equation of the circle was x plus 5 plus y minus 1 whole square is equals to 45. So this was x plus 5 plus y minus 1 whole squared is equals to 45. Now in place of y, we can substitute it with 2x plus 6. So substituting 2x plus 6 in place of y, we get 2x plus 6 minus 1, which will become a 2x plus 5 whole square is equals to 45. And this was a x minus 5. So let's correct this as well. So this would be x minus 5. Now expanding this equation, we get x squared minus 10x plus 25 plus 4x squared plus 5 to the 10 times 2, 20x plus 25 is equals to 45. Simplifying, we get 5x squared minus 10x plus 20x is a plus 10x. 25 plus 25 is 50. 50 minus 45 is a plus 5 is equals to 0. We can simplify it down to write it as x squared plus 2x plus 1. So we'll get x squared plus x plus 1 is equal to 0. We have x into x plus 1 into x plus 1. So as we have repeated roots, we know that the x coordinate would be x equals to -1. And to get the y coordinate, we can just substitute into the equation y is equals to 2x plus 6. So substituting x is equals to -1, we get -2 plus 6, which is +4. So the coordinates of E are -1, 4. And as we had already drawn the diagram, we can roughly see that the y value is roughly positive and the x value is somewhat negative. So the coordinates of E are -1, 4. In this question, we have a curve which we have to for which we have to find the derivative, the double derivative, and the integral. To find the derivative, we make sure that our expression is in the numerator, so we write it as 2 multiplied by 3 minus 2x to the power -2 minus x. Differentiating, we get dy dx is equals to, so the power multiplies with the coefficient, this will become a -4 into 3 minus 2x, and we multiplied by the derivative of this function 3 minus 2x, which is -2. The power decreases by 1, so it becomes a -3. Differentiating minus x, we get a -1. So the simplified form will become -4 times -2 would be +8. So we can write this as 8 divided by 3 minus 2x to the power 3 minus 1. For the double derivative, we differentiate the dy dx that we got over here. So we will multiply the minus 3 by minus 4, which will become a 12 into 3 minus 2x. The power decreases by 1, so it becomes a minus 4. And we again multiplied by the derivative of 3 minus 2x, which is minus 2. And the derivative of minus 1 is 0, so it will become a 0. So the answer would become minus 24 over 3 minus 2x to the power 4. To integrate the function, so the last thing is we have to integrate the function y. So again, we'll bring it in the numerator. So this will become 3 minus 2x to the power minus 2. Now, when we are integrating, we increase the power and then divide by the new power. So this would become 2 multiplied by 3 minus 2x minus 1. When we add 1 over here, so this will become a negative 1. And we divide by the new power, which is minus 1. And we also divide by the derivative of 3 minus 2x, which is minus 2. Integrating minus x, we get minus x square upon 2, and we always put a plus c if we have no limits. So the negative signs will cancel out, the 2 will cancel with the 2. We can write a final answer as that the integral of the function y is 1 over 3 minus 2x minus x square upon 2 plus c. Now in the next part, we have to find the x coordinates of m. Now, as you know that m is the minimum point on the curve. So on that point, the dy dx would be a 0. So first of all, we can start off by writing that the dy dx would be a 0 for the minimum point m. The dy dx was 8 divided by 3 minus 2x to the power 3 minus 1 is equal to 0. Taking the 1 on the other side, we get 8 upon 3 minus 2x to the power 3 is equals to 1. Simplifying, we get 8 is equals to 3 minus 2x to the power 3. Taking the cube root on both the sides, we get 2 is equals to 3 minus 2x. So we can bring the 2x on this side, and this will become 3 minus 2. So x would become 1 upon 2. So this is the x coordinate of m. In the last part, we have to find the area of the shaded region bounded by the curve and the coordinate axis. So we have to find this region. We know that the value of m is 1 upon 2 and the lower limit is 0. And we already have the integral of this function. So to find the area, we use the integral, which is 1 upon 3 minus 2x minus x squared upon 2. And we also have the limits, which is 1 upon 2 and 0. So substituting 1 upon 2 into the equation, we get 1 upon 3 minus 2 into 1 upon 2 minus 1 upon 2 whole square, which is 1 upon 4 upon 2 minus, we'll substitute 0 into the equation, we get 1 upon 3 minus 2 into 0, which is a 0, minus 0 upon 2, which will be a 0. So this 2 and 2 will cancel out. We get 1 upon 3 minus 1, which is 2, minus 1 upon 8, minus 1 upon 3. Simplifying, we get the area is 1 over 24. In this question, we have an equation y is equal to 3 cos 2x plus 2. For x is greater than 0 and less than pi, we have to state the greatest and least value of y. So for the greatest value, we can just add this 2 and this 3 up here. So the greatest value will become 5. And for the least value, we simply subtract the two values. So the least value would be a minus 1. Now to sketch the graph of this function, we know it goes from 0 till pi. As it is a 2x, it means in 0 till pi, it will have one cycle. The highest point is 5. The lowest point is negative 1, as we have seen from the first part. So let's say this is pi upon 2 and this is pi. So the curve starts from the highest point, which is 5. So, and an easier way to construct graphs is you can just simply substitute values of 0, pi upon 2 and pi into the equation. So substituting 0 into the equation, we get 3 cos 2 times 0 plus 2. So cos of 0 is 1, so the highest point is 5. When we substitute pi upon 2, we get minus 1, and when we substitute pi back again, we get 5. So we can make a graph, the cos graph, like this. Now in the next part, we have, by considering the straight line y is equals to kx, we have to state the number of solutions of the equation. So the number of solution means the points basically at which the line and the curve will intersect. So when k is equals to minus 3, it means the equation is y is equals to minus 3x. So first of all, we'll construct the line y is equals to minus 3x. So roughly that line would be, let's take x equals to -1. So y will be a positive 3. And if we take x as positive 1, y would be a minus 3. So roughly the line, it will be passing through the origin, as when x is 0, y would be a 0. So roughly the line would be like this, and it will be passing through the origin. Okay, so we can see from the curve and the line that they are not intersecting, so we can write that they have no solutions. And we'll have to make sure that we show that this passes through the origin. Now in the next part, k is equals to 1, which means the equation is y is equals to x. Now when we make the curve for y is equals to x, it means when x is 1, y is 1, when x is 2, y is 2, and so on. So the line would be somewhat like this. Now we can see that they're intersecting at 2 different points, so the answer would be that it has 2 solutions. And for k is equals to 3, the equation would become y is equals to 3x. So the line would be somewhat like this. And we can see that for this part, there is only one solution. And the next part, we have that function. There are 3 functions f, g, and h. Describe fully a sequence of transformation that maps y f of x onto g of x. Now, what we have to understand is that f of x is 3 cos 2x plus 2, and g of x is f of 2x plus 4. Now, when this basically, when the value of x over here is doubled, basically this represents a stretch with scale factor half and parallel to the x-axis. So let's say if we have a function f of x and it is transformed to f of 2x, it means basically it is a stretch factor half parallel to the x-axis. So this is parallel to the x-axis, and this plus 4 basically represents a simple translation in the y direction. So the plus 4 means that the graph will shift 4 units upward. So we can say that this is a translation with vector 0 and 4, as there is no movement in the x direction, and it has a movement of 4 units in the y direction. So basically these are the 2 transformations that transforms f of x onto g of x. Now in the last part, we have to describe a sequence of transformations that map y is equals to f of x into y is equals to h of x. So comparing this, we can see that h of x is 2 times f of x plus half pi. Now, when it is x plus half pi, it basically is a translation in the x direction. So this represents a translation of, so this will be a negative half pi and negative half pi in the x direction and 0 units in the y direction. And this too represents a stretch. So when the function is multiplied by any constant, it represents a stretch in the y direction, stretch in which is parallel to the y-axis. So we can say stretch parallel to y-axis, and the stretch factor would be 2.